Now we move on to learning about the product rule. If I were to ask you to take the derivative of a certain function that kind of looks like this, we have two kind of distinct terms with variables in both of them. For example, we have an example right here, x squared times sine x. Your first initial instinct might just be to treat this as if it were x squared plus sine x, and I ask you to take a derivative of that. And we all know that if you were to take a derivative of that, that would be pretty because of the addition in calculus, where you could just do the power rule on both of them, or you could do the power rule on the first one, and you'd end up with 2x, and then you could treat both of them really as separate. What I'm trying to get at is that you could really treat both of the terms as separate functions, where you could take the derivative of x squared, which is 2x, and add that to the derivative of sine x, which is cosine x. And that would be your derivative. However, if I were to say that this is a multiplication problem, you might try to do the same thing, and you might try to say, hey, maybe it's just 2x times cosine x. And you couldn't be more wrong if you did that. And let me tell you why. It's because of a thing called the product rule, which is what we're doing today. So the product rule says that if you have this, which I just explained before, if you have two separate so if you have two separate parts or terms with variables inside it, as we saw in this example, where you could really divide this into two separate terms, where you have the x squared and the sine x with different variables in it, and you're multiplying them, you have to use the product rule when differentiating. And the product rule says that you have to follow this kind of format when you're doing this. And let me just write that down. It says f prime of x times g of x plus, let me zoom out over here, f of x times g prime of x. So if you have something, as we mentioned before, two different terms with independent variables, you're going to have to follow the product rule right over here. So the product rule is basically saying that you have to add these two terms together, where you're in the first one you're taking the derivative of the first times the second plus the first times the derivative of the second, and we're referring to these as first and the second. So the derivative of the first times the second plus the first times the derivative of the second. So you kind of have to just remember that, because you'll have to use that when you're differentiating. So this is basically what it is. That is the product rule. And we can go ahead and try to apply that to the example that we tried to do earlier. But now that we know the product rule, we should be able to do it successfully. So I'm going to go ahead and write this down. So we have dx. I'm taking the derivative of x squared sine x. Now, for simplicity's sake, or for the sake of actually helping you understand, what I'm going to do is I'm actually going to go ahead and identify our two terms. So the first term over here is x squared, and the second one is sine x. And once we've done that, we've kind of already done half of what we have to do, as long as we can identify them successfully. So the next step is writing. So when you're really familiar with the product rule, you could just do it because you'd really remember what the product rule is. But I'd recommend that if you're new to the product rule, go ahead and actually write down the first and the second. So you can write them down as f of x and g of x. So we can say f of x is equal to x squared, and we can say g of x is equal to sine x. And then we can actually use our knowledge of the power rule to apply that over here and find f prime of x, and that's going to be 2x. And we can also use the trig differentiation that we've learned before to know that sine of x, the derivative of sine of x is cosine of x. So now once we have all this information down, it's really just a matter of arranging it in order to get the derivative of the original problem that we're tackling. So you can try and remember this. You're not going to have this on any formula sheet or anything, so you should probably learn that, or really definitely should learn that. And so what we're going to do is we're going to do f prime of x, so that's 2x, right here, f prime of x, that's 2x, times g of x, oh, that's the problem right there, that should be g prime, times g of x, which is sine x, g of x, which is sine x, plus, and then we're going to add f of x, which is going to be x squared. So we're going to have x squared times g prime of x, which is cosine x. And that, there you go. That is the derivative of this problem right here. 2x sine x plus x squared cosine x. So, and even though you've gone over the product rule now, I'd really recommend that you actually practice this as much as you can, because a lot of the times when you advance further on into calculus, you'll kind of forget the product rule. You'll forget actually applying it into problems. So you might actually just be doing calculus, and let's say you see a problem like the one we just mentioned, you see x squared sine x, and you honestly might just, the product rule might just fly over your head, because at this point you're doing so many more things, and you might just end up doing 2x cosine x, because that's really how you do it when you're doing all the polynomials, as we discussed before, such as, I don't know, 3x squared plus 6x. You wouldn't be wrong if you were to treat them like individual terms in this instance, because it's adding the polynomial, or it's a polynomial. So you could just do product rule on 3x squared, you get 6x plus 6. But you can't really do that with multiplication. And it's important to remember that when you get these, you have to use the product rule.